Hello students, welcome to Target IES. In this video, I am going to continue with module number 11 of soil mechanics. We are going to start very fresh chapter soil structure and clay minerals. All the basic concepts like soil water ho gaya, bulking of sand. You might have heard this term, right? Bulking of sand. We will study that concept also in the same module. And after that, we will be seeing this soil structure like honeycomb structure, flocculent, dispersed. All these things we will be seeing in the next module, module number 12. And in module number 12 only, I would try to sum up this chapter with clay minerals also. Clay minerals and coyolite, illite, mortmelite, everything will be covered in these two modules, module number 11 and module number 12. This is a very basic chapter, theory chapter, no numericals will be asked. That too, this theory is important for small exams like SSC, JEE, State PSC. So please concentrate. Okay, a bit can come from anywhere. So please concentrate on this topic. Now coming to the soil water, the very first topic which I am going to teach. There are four types of water which you have to understand. Okay, in soil there are four different types of water present. Let us try to imagine this. So below the ground level, okay, just go outside your home, wherever you are standing, let us say that is the ground level. Below the ground level, somewhere here we will be having our groundwater table. We will be having our groundwater table. So below groundwater table, you know what is flowing, groundwater is flowing. Okay, all this soil below this is completely saturated. So this zone is also called as zone of saturation. Okay, groundwater table के नीचे के zone को हम क्या बुलाते हैं? Zone of saturation. Fine. So the water which is present in this zone, we are calling it as groundwater. And what is the force acting on groundwater? It is gravitational force. Okay, it is gravitational force. So my groundwater will be flowing in the direction in which the gravity is pulling it. Common sense की बात है. Okay. So I hope things are clear. So all the laws of hydraulics are valid for your groundwater. ठीक है. जैसे continuity equation हो गया, whatever equation you want to apply of hydraulics, you can apply for your groundwater, no issues. Now let us see the second type of water. So second type of water is adsorbed water. नाम ही कह रहा है. The water which is adsorbed on our soil solids, we call it as adsorbed water. There are two types of adsorbed water. One is hygroscopic water, second is film water. So what is it? So hygroscopic water is nothing but the water which got adsorbed on this soil solid. Okay, from atmosphere we are calling it as hygroscopic water. Okay, water adsorbed by soil solids from atmosphere and retained over solids due to adhesion, we are calling it as hygroscopic water. I hope you remember these terms, right? Adhesion and cohesion. याद है फ्लूइड मैकेनिक्स में मैंने ही पढ़ाया था ना, cohesion. So if you have intermolecular forces between molecules of same nature, तो हम क्या बुलाएंगे? Cohesion बुलाएंगे. Okay, so intermolecular forces between particles of same nature. For example, if you are taking clay, so clay are bonded with each other. So this force whichever is acting in between these particles, I am calling it as cohesion, because A भी clay है, A भी clay है. So all particles are of clay. So there is some bonding in between them. Intermolecular forces is there present in between them. We are calling it as cohesion. Okay. So what is adhesion? For example, just dip your finger in water. Okay. So what is happening? When you take your finger out, you will be feeling the water is present on your finger, right? क्या हुआ है? There is some affinity between your water molecule and your finger. Okay, if there is intermolecular force of attraction between molecules of different nature, if there is intermolecular force of attraction between molecules of different nature, we'll be calling it as adhesive forces or adhesion. Okay, so dip your finger in water, take it up, you will feel there is some wetness on your finger. This is because of adhesion between water molecule and your finger. Okay, things are clear. I hope you understood what is difference between adhesion and cohesion. मैंने hint भी दिया था आपको how to remember. See, you might be confused after some time, like after like 3 months or 4 months, you will be confused in between adhesion and cohesion. What is the hint I have given? Remember in alphabetical order. Okay, A B C D E F G H I J K L M N O P Q R S T. Okay, remember in the alphabetical order. So D, yes, in alphabetical order I am writing these terms. So adhesion is for different particles, cohesion is for same particles. Okay, this is how I remember, because the confusion is between mostly different कौन सा है, similar कौन सा है. Okay, so just write these terms in alphabetical order. So adhesion का क्या आ जाएगा? D आ जाएगा, which is different particles. Cohesion का क्या आ जाएगा? Similar particles. Okay, that's how I remember. Maybe it will be helpful to you also in some or some exam. So what is happening here, let us try to understand this hygroscopic water, which is right. So it is tightly packed, okay, it is densely packed. So what it will have high boiling point and viscosity. As it is tightly packed, वो easy से नहीं move कर रहा है. Therefore what is happening, if it is not moving easily, we will call that viscosity high, or low, we will call that viscosity is very high. So this water which is densely packed surrounding this soil solids, it will have high boiling point and viscosity and low freezing point than compared to that of normal water. Things are clear? So I hope you understood what is this adsorbed water, right? Finer the particle, more surface area will be there, so more water will be adsorbed. Obviously common sense की बात है, you already know, right? If particle is finer, so if you have fine soil, then what will happen? Your surface area will be more compared to that of coarse grain particles. So what will happen? More water will be absorbed for fine grain particles compared to that of coarse grain particles. Okay, so this is the first type of adsorbed water, hygroscopic water. I hope you are perfect, right? Now let us see what is this film water. On this hygroscopic water, let me round it up. If this is soil, on soil you will be having this hygroscopic water. On this hygroscopic water, there will be one more film formed. Okay, this is because of condensation of aqueous vapors on the soil solids. Because of the condensation, you will be having one more layer, and this layer we are calling it as film water. Things are clear? So it is due to condensation of aqueous vapors over the film of hygroscopic water. Okay, so basically I told you, the finer the particles, more is your adsorbed water, right? More is your adsorbed water. So you can see for clay it is around 16 to 17%, whereas for silt, because clay is finer, right, compared to that of silt, and silt is finer compared to that of sand. So you can see the magnitude. In clay, water content which got because of this adsorbed water is around 16 to 17%, whereas for silt it will be just 6 to 7%. Okay, so for sand it is more coarse, right? तो surface area काफी कम रहेगा. So as surface area for the sand is less, it will be having only 1% of water content because of this adsorbed water. Things are clear? Things are clear? Everything is fine, right? Now let us see the structural water. I have already explained the structural water once, right, in before chapters. What is it? The water which is chemically combined in crystal structure of minerals itself. It is present inside your soil solids. Okay, सॉइल का जो भी मिनरल कंटेंट रहेगा उसके अंदर जो वाटर मॉलिक्यूल्स प्रेजेंट रहेंगे उसे हम कह रहे हैं स्ट्रक्चरल वाटर. वाटर विच इज केमिकली कंबाइंड टू द क्रिस्टल्स ऑफ स्ट्रक्चर of soil minerals, we are calling it as structural water. Under normal operations this water cannot be separated. Okay, as it is present inside soil solids, वो बाहर आप निकाल नहीं पाओगे. Okay, if you are heating to in oven dry method, I have told you, in oven dry method we are heating only up to 105 degrees to 110 degrees in inorganic soil, so that our structural water is not evaporated. Okay, so if you are heating more than 110 degrees, only then your structural water will be released. So in oven dry method, what is our limit? 110 degrees. Okay, so if you want to remove the structural water, you have to heat at very high temperature, more than 110 degrees, तभी ये water release होएगा. Things are clear? Now let us see the last type of water, which is capillary water. See, due to the surface tension, what is happening? Some of the water from this groundwater table, it is being lifted above. Okay, so this water is called as capillary water. Let us try to understand. This is my groundwater table, right? Let me change the color. So this is my groundwater table. Below this, the soil is fully saturated. Okay, above here we have some zone of aeration. Here we have zone of aeration. The top layer, okay, we are calling it as zone of aeration. So the layer which is just above this zone of saturation, now above this groundwater table, it will be also saturated. How? Let us try to understand. See, when I am talking about soil solids, right, it will have some voids. Agreed? It will have some voids, and in these voids there will be some capillary action. Because of this capillary action, what is happening? My water is rising above this groundwater table. Okay, actually gravitational forces upward direction में act करते हैं, downward direction में act करते हैं. It is acting in downward direction. Gravitational forces is acting downward direction. So basically water, it should flow from top to bottom. But here what is happening? The water is flowing against the gravitational forces and trying to go up. Agreed? So this is called as capillary action. Because of this capillary action, we are getting this zone of capillary saturation. Okay, zone of capillarity or you can also say zone of capillary saturation. Things are clear? Okay. Now let us read this definition and then I will derive this formula in like 10 seconds. जरूरत नहीं है derive करने की soil mechanics में. This is the concept of fluid mechanics, but just for making you feel easy, I will derive it once again. Okay. So capillary water. Due to the surface tension, I have told you there will be adhesion between soil particles and water. So because of this adhesion yani there is some affinity between solids and water. Because of this affinity, what is happening? The water is being lifted above. Okay, because of this surface tension or because of this affinity, the water is being lifted above, and the water which is lifted above this water surface, we are calling it as capillary water. Okay, so above this groundwater table, whatever water it is raised, right, we are calling it as capillary water. This water has raised against the gravitational pull. You have to remember this. Okay, so this water fills the void of soil up to certain distance above the water surface, and this zone we are calling it as zone of capillary saturation. Up to this saturation zone, we are calling it as zone of capillary saturation. Things are clear? Everything is fine? So let us derive this. Very simple. Very simple. In fluid mechanics, we used to take one capillary tube and immerse it in water, right? Capillary tube in general, it will be less than 1 centimeter dia, and we just have to immerse in water. When we immerse in water, थोड़ा बड़ा डाल लूँगा. Actually it should be less than 1 centimeter, but दिखेगा नहीं, इसलिए थोड़ा बड़ा डाल रहा हूँ. ठीक है? So if you are taking big tubes, you won't be seeing any rise because it is inversely proportional to diameter. अगर diameter आपका बड़ा हो गया तो height of rise काफ़ी कम हो जाएगा, negligible हो जाएगा. If you are taking diameter very less, then obviously your height of rise will be more. Okay. So what is happening here? There will be certain rise in water surface because of this surface tension. Obviously, you know, the water जो भी rise होगा in tubes, you might have seen in chemical laboratory, right? You have done lot of experiment with pipette, burette. Water level कैसा रहेगा? It will be in a form of meniscus here. Okay. I hope things are clear. So there is some tension acting, the surface tension acting, which is lifting this water up to certain height, and this height I am calling it as capillary height. Okay, HC, capillary height. Okay, how to calculate this capillary height? The height the water has risen above its original surface, we are calling this capillary height. How to calculate? Very simple, very simple. Here your tensile force is acting, right? Here your tensile force is acting. 2 dimension में इस तरह से दिख रहा है, but in 3 dimension, just imagine we have a circular tube, right? We have a circular tube. All around this circle there is water which is in contact with the glass, so surface tension all over the circle act कर रहा है. Okay, all over this it is acting. 2 dimension में मैं इस तरह से represent कर रहा हूँ. Okay, originally it is acting all over the surface. So what is the surface tension? Let us say Ts, and let us say this angle is some alpha. This angle is alpha. So what is the upward force which is acting? Upward force which is acting is Ts cos alpha. Okay, Ts का component in upward direction, it will be Ts cos alpha into pi d, perimeter of the circle, because it is acting all over the tube, right? It is acting all over the tube. So perimeter of the circle into the force Ts cos alpha. This is the total force which is acting, which is lifting your water up. Okay, so in general your surface tension force will be equals to weight of water. Up to what extent it will rise? Because of the surface tension, up to the height till the weight of water which has been raised, right? It will be equals to your surface tension, वहाँ तक का rise रहेगा. Okay, so this is equals to weight of water which has been lifted in this capillary tube. So what is the weight of water in this zone? Height कितना है? Height आके hc है. Okay, height is hc. So what is the area? Area of tube. What is area of tube? Pi by 4 d square. Okay, so this is the volume. But if you want weight, what to do? You know volume, you want weight, what to do? Just you know gamma w is equals to weight of water divided by volume. So if you want weight, just send it here, gamma w into volume. So just into gamma w. Okay, so pi cancel, ad cancel, square cancel. So if you want hc, you can send 4 above. So 4 Ts cos alpha divided by we have gamma wd. So this is my formula, as simple as that. A to a derivation. Okay, if you are assuming this alpha is equals to 0, right? If you are assuming this is acting perfectly straight, ऊपर ही act कर रहा है surface tension, this is the assumption. Actually alpha रहेगा. If we are assuming it is alpha is equals to 0, then cos alpha will be 1, right? If alpha is 0, cos alpha कितना हो जाएगा? Cos 0, it will be 1. So I can write 4 Ts gamma W D. So this is my H maximum. Okay, H maximum कब आएगा? When alpha is equals to 0. So your maximum height which can be raised in the capillary tube, which is 4 Ts gamma W into T. Very simple, right? Gamma W into D. Very simple. I hope you are perfect. So you can see your height of rise is inversely proportional to your diameter. Height of rise is inversely proportional to diameter. अगर diameter छोटा है तो height जाएगा, अगर diameter बड़ा है, बड़ा ट्यूब ले लो आप, बहुत ही कम height rise रहेगा. Things are clear? So as it is inversely proportional to D, I can also write it is inversely proportional to R, right? Okay, things are clear? So basically at 20 degree centigrade ये जो surface tension TS रहेगा, it is 72.8 into 10 to the power of minus 8 kilonewton per meter. So if you are substituting, you will be getting this equation. Your height in your capillary tube, it will be 0.29 divided by D centimeters. Okay. Now let us apply this concept in soil. Okay. So we have done this experiment in laboratory by using capillary tube. We got Hc is equals to 4 Ts cos alpha by gamma Wd. Very good. But now let us apply this in real life condition. Soil क्या होगा? Let us try to understand. Okay, let us try to understand. So when I have solids, let us say this is my soil solids, and water कहाँ पे rise हो रहा है? In this voids, right? In between this soil voids, we are getting soil के जो भी voids रहेंगे वहाँ पे पानी रहेगा. So water it will be same in the form of meniscus. जैसे वो ट्यूब में रहेगा, कैपिलरी ट्यूब में meniscus वैसे ही रहेगा. Things are clear? So now tell me, so what is the D here? When I am using this D, right, in formula we are using D, right? So it is not, many people confuse, it is a diameter of solid. Solid का diameter नहीं है बाबा, वाटर ट्यूब का diameter था ना इन कैपिलरी राइज, वाटर ट्यूब का diameter था, यहाँ पे भी वैसे ही रहेगा. It is the diameter of voids, or to be precise you can say here you are following this meniscus, right? एक meniscus आ रहा है, so यहाँ पे तो surface tension यहाँ पे add कर रहा है ना, so you can say it is the diameter of your meniscus, or in simple language diameter of your voids, but more precise diameter of your meniscus. Things are clear? I hope you understood this point, right? So your height of rise in your soil, it will be 4 Ts gamma W into D, where D is diameter of meniscus. Or you can write, instead of D you can write 2R, where R is radius of meniscus. So 2 cancel, you will be getting 2 Ts by gamma W R, where R is your radius of meniscus. Now let us try to understand what is happening in this soil. See, first of all you have some meniscus like this. Okay, when water level is less, you will be having some meniscus like this. But as your water content is increasing, okay, as more water is present in between soil solids, now what will happen to this meniscus? Meniscus will getting straightened. Okay, पहले meniscus था कुछ इस तरह से. Okay, it was something like this. Now it is getting more water content, so slowly it is getting flatter. Okay, so previously let us zoom this diagram. Previously my it was something like this, my meniscus was something like this. Okay, so as the water content is increasing, what will happen? This meniscus will start to get straighten up, so it will be getting straighten up as your water content is increasing. Agreed? So what is happening to your R value as your water content is increasing? What is happening to your R value? Let us try to understand. So previously in the first case, when you have something like this, when you have meniscus something like this, so what was your radius? Circle form kar lena. So this was your radius. Okay, this was your radius. Radius was very less. Now when it got straightened up, when it got little bit straightened up, so what is happening? एक circle डाल लेना, you are getting a bigger circle. So you, what happened to your radius? Radius is increasing. Okay, when it got flattened, for example, the water content has raised to the extent, okay, fully saturate हो गया है, fully saturated case. So what is your R value now? R value is infinite. You cannot draw a circle, right? इतना बड़ा circle है, तो R infinite हो जाएगा. Okay, so when R is infinite, what will happen to your HC? What will happen to your HC? 2 Ts gamma W R. R is infinite, so your HC value is 0. Things are clear? So if you have soil which is fully saturated, अपना capillary action उसमें नहीं दिखेगा, it will be 0. Capillary rise, if the soil is already saturated, then there won't be any such capillary rise in that soil. Okay. Now I will introduce you a new term which is contact pressure. Okay, so because of this contact pressure in soil, what is happening? There is a phenomena being developed called as apparent cohesion. You know what is cohesion, right? Intermolecular forces of attraction between particles of same nature. Okay, but what is this apparent cohesion? Let us try to understand. See, because of this cohesion, there will be some intermolecular forces present between silt and clay. We have told you only in fine grain soils you will be seeing this cohesion. Okay, in sand you generally don't see this cohesion, but because of this contact pressure, right, even in sand you will be seeing certain type of cohesion. Okay, there will be some force of attraction. What is that? Let us try to understand. What is this contact pressure? Let us try to understand. See, because of this surface tension, what is happening? The water is rising. This, because of this capillarity action, the water is rising. Now this water is exhibiting tensile forces on these soil solids. Let us try to understand. We have soil solids like this. दो ही soil solid नहीं रहेंगे ना, we have infinite mass. Okay, so what is happening? We have infinitely many soil solids. In between these voids, what is happening? Somewhere here, okay, if I zoom it properly, somewhere here, okay, I have my meniscus. Okay, I have this water here. Okay, I have this water here. Okay, so what is happening? This is pushing the soil solids away. Okay, there is some tensile force being acted. So this cannot go anywhere, right? This soil solids cannot move because let us try to understand. If there is some force being acted, it cannot move this direction because यहाँ पे already solids है. So what is happening? There is some compressive force being developed on the soil solids. Common sense की बात है. The water is exhibiting tensile force. So obviously this whatever solids, right, it is executing this compressive force. Common sense की बात है. So there will be some force like this in between soil solids. So what is this happening? There is some apparent cohesion. Okay, this is not actual cohesion, but because of this capillary tension, what is happening? There is some apparent cohesion being developed. There is some force of attraction between soil solids that is called as contact pressure. I hope things are clear, right? The pressure which has been developed in between the soil solids, we are calling it as contact pressure, because as they are being in contact, now as the tensile force is increasing, what is happening? More the tensile force, more your contact force will be, the more your contact pressure between soil solids will be. Common sense की बात है. I hope things are clear, right? I hope you're perfect in this thing. So because of this apparent cohesion, what is happening? Even this sand particles, you will feel they have some affinity. Okay, तो क्या हो रहा है? Strength बढ़ रहा है. Because of this apparent cohesion, what is happening? Your strength of soil is increasing. Okay, so what is happening? Now let us try to understand. See, this is a very important bit. Your capillary tension, right, it has many names. It can be also called as capillary potential, one and the same. Whenever I am using capillary tension, it is same as capillary potential. अगर एग्जाम में दे दिया capillary potential, confuse मत हो जाना, it is same as capillary tension. Or it can be also called as soil suction. Okay, soil suction or pressure deficit. All these names are of capillary tension only. Okay, capillary potential, soil suction and pressure deficit. Okay, so what is happening? As our water content is increasing, okay, because of this capillaries, what is happening? Our water content in soil is increasing. Because of this water content rise, our radius of our meniscus is increasing. Previously it was something like this, but more water content, this is getting straightened up. मैंने समझाया था ना अभी ऊपर. So as it is getting straightened up, your surface tension will be decreasing, and so your contact pressure will be decreasing. Okay, more it is, what is happening? Surface tension कम रहा है. अगर surface tension कम रहा है तो tensile forces कम रहा है, तो compressive forces भी कम रहा है. Your contact pressure is decreasing in between solid particles. Things are clear? Okay, more the water content, your contact pressure will be less. So capillary water is in the form of contact moisture. Due to the tension, the water forces the soil particles to press against each other and contact pressure is being developed. This leads to apparent cohesion. I hope things are clear, right? Because of this contact pressure, what is happening? There is apparent cohesion between solid particles and it improves the compressive strength of soil. Okay. But as you are continuously adding water, what is happening? Your radius of meniscus is increasing, your surface tension will be decreased. If tension is less, obviously your contact pressure will be less. If your contact pressure is less, this apparent cohesion will be slowly going out. Okay, I hope things are clear. And slowly your soil will be losing its compressive strength. As you are saturating, it will be losing compressive strength in this zone. Things are clear? Okay, see, one important thing you have to understand. So far you are perfect. So far you are perfect, right? One more thing you have to understand, this concept whatever you have read, HC is equals to 4TS divided by gamma WD. Cos alpha भी रहेगा. If you neglect cos alpha, this was the formula which you have got. But this is when you have a vertical tube like this capillary tube. But imagine karna, but when you are taking our soil in natural condition, you have voids in vertical direction and horizontal direction also. Agreed? So we cannot exactly use this formula. We have to modify this formula. How to modify? Let us try to understand. We have to take, instead of d, we don't know this d, right? We don't know this d value. So we have to take this effective size of d to accommodate this horizontal and vertical void direction, right? So we are taking this d as d10 divided by 5. Okay, what is d10? Effective size. Okay, effective size of your soil solid d10 जो भी आएगा, so d10 divided by 5 कर लेंगे तो हमारा effective size of void आ जाएगा. Things are clear? So d10 by 5 or you can say 20% of d10. So just d10 by 5 आप substitute कर लेना यहाँ पे, instead of d10 by 5 कर लेना, तो आपको क्या आ जाएगा, 5 न्यूमरेटर में चले जाएगा, so you will be getting 20 TS by gamma W d10. कॉमन सेंस की बात है. ओके, सो योर HC मैक्सिमम विल बी 20 TS gamma W d10. रिमेंबर, इंपॉर्टेंट फॉर ऑब्जेक्टिव पर्पस. सो देर इज वन मोर फॉर्मूला विच वॉज गिवन बाय हेजन. वो भाई साहब ने डायरेक्टली दे दिया था, HC मैक्सिमम इज इक्वल्स टू C by E into d10. ओके, where d10 is in centimeter, so your formula is C by E d10. Very simple formula, right? C by E d10, and C, it was a constant which was ranging from 0.1 to 0.5 centimeter square. Okay, things are clear. See, there is one more assumption. See, we can assume our voids are spherical. Even our voids are spherical, we can assume this. So if my voids are spherical, then what will be volume of voids? When I am taking sphere, right, our volume will be proportional to diameter cube. So volume of voids is d cube. So similarly, volume of solids will be effective size. Effective size is d10 ka cube. Okay, so I can write my void ratio Vv by Vs as d cube by d10 cube now. Agreed? So what will be my d? D will be E to the power of 1 by 3 d10. Agreed? Because I have just sent it here, cube का इधर चले गया तो क्या आ जाएगा, 1 by 3 आ जाएगा. Okay, so d is equals to E to the power of 1 by 3 capital D 10. Okay, things are clear. So if I substitute this, I will be getting HC max is equals to 4 TS gamma W E to the power of 1 by 3 d10. So these are the various forms of HC maximum we have in our soil mechanics. Okay, so I have told you our HC is inversely proportional to diameter. So what is happening, if you have a fine grain soil, then our capillary rise will be more, because if I have fine grain soil, the voids is also very less, right? The voids area will also be very less because they are tightly packed. So what is happening, the rise will be more. If you are taking coarse grain particles, they are loosely packed. Okay, वो सीधा पैक नहीं होते हैं because they have coarse grain particles, so there is lot of void distance also. As there is lot of void distance, the void is more, therefore what is happening, the capillary rise will be less. ये याद रखना bit, capillary rise is more in your fine grain soil compared to that of coarse grain soil. Things are clear? So you can write, you can remember this table also, not that important, एग्जाम में नहीं पूछेगा बट कॉमन सेंस के लिए. इन ग्रेवल योर कैपिलरी राइज विल बी एज लेस एज 2 to 10 सेंटीमीटर, वेर एज इन सैंड इट कैन बी अप टू 10 to 100 सेंटीमीटर ऑल्सो. ऑलमोस्ट 1 मीटर तक राइज रह सकता है इन सैंड में. इन सिल्ट इट कैन गो अप टू 1 मीटर टू ऑलमोस्ट 10 मीटर्स. ओके, 10 मीटर्स लंबा तक, ऑलमोस्ट 3 स्टोरी बिल्डिंग के हाइट तक रेस रह सकता है कैपिलरी राइज, जोन ऑफ कैपिलरी जोन. ओके, एंड फॉर क्ले इट विल बी इवन मोर बिकॉज इट इज इवन फाइन, राइट? It can be from 10 meters, 1000 centimeter yani 10 meters, right, to 30 meters. Okay, things are clear. I hope you are perfect in this concept. Now let us see bulking of sand. See, bulking of sand is because of moisture content. Okay, let us try to understand what is happening. First of all, when the soil is in dry state, if I am taking this sand, it is a coarse grain, right? It doesn't have any cohesive forces in it. Okay, कोई cohesive forces नहीं है, strength काफ़ी कम है इसका, and the sand will be generally in coarse grain structure, something like this. Because of the gravity, random orientation रहेगा, something like this. There is no specific shape and we call it as coarse grain structure. पढ़ेंगे details है, no issues. So here you can see this is how coarse grain structure will be seen. No particular shape, as the gravity force is pulling it, उसी shape में आ जाएगा. Things are simple, right? Now what is happening, strength काफ़ी कम रहेगा. Now what is happening, as soon as you are adding water, okay, when you are adding water, what will happen, contact pressure का concept पढ़ा था ना, contact pressure will increase as your water content is increasing in the sand. If you are adding some water, water content is increasing, बिकॉज ऑफ इट कॉन्टैक्ट प्रेशर इज इंक्रीजिंग. कॉन्टैक्ट प्रेशर बढ़ेगा तो अपरेंट कोहेजन बढ़ेगा. देर विल बी सम cohesion in between the soil solids. So what is happening? Soil solids can now have certain strength and they will reorganize the structure. Okay, honeycomb structure में modify हो जाएंगे. Okay, generally ये honeycomb structure दिखता है सिर्फ fine grain solids में. But now what is happening, as it got some apparent cohesion, now it has some intermolecular force of attraction similar to that of intermolecular force of attraction, and it can rearrange itself into the honeycomb structure. So what is happening, your volume of voids is increasing now. Okay, as it got some strength, it can rearrange in a better way and it is getting a honeycomb structure. So what is happening, your volume of voids is increasing. Okay, so this is called as bulking of sand. As you are adding some amount of water, what is happening, your volume of sand is increasing. Okay, the sand which is slightly moisture shows increase in volume compared to that of dry volume. So this increase in volume we are calling it as bulking of sand. Why is this increase is there? Because of apparent cohesion. Okay, apparent cohesion. Because of apparent cohesion, now it can hold the soil particles in a better way. It can hold the solid particles in a better way. It will hold in a form of honeycomb structure. Honeycomb structure यानी हम पढ़ेंगे. So it will be something like this. Generally it will be in फाइन ग्रेन सॉलिड्स ओनली. अगर इस तरह से कोई स्ट्रक्चर रहना है, सो ऑब्वियसली देयर शुड बी सम इंटरमोलिकुलर फोर्स ऑफ अट्रैक्शन, राइट, तभी तो रहेगा, और एल्स इट विल बी कोलैप्स, इट विल बी समथिंग लाइक दिस, इट वोंट बी लाइक दैट. ओके, सो इफ इट इज समथिंग लाइक दिस, इट इज ओनली बिकॉज ऑफ इंटरमोलिकुलर फोर्सेस ऑफ अट्रैक्शन जो सैंड में नहीं है. सो इन क्लेस एंड सिल्ट ओनली यू विल बी सीइंग this honeycomb structure in general. But what is happening, when in sand you are adding water, there is some apparent cohesion, so it can rearrange itself into honeycomb structure and we are seeing this bulking of sand. Okay, things are clear. मैंने आपको एक और चीज़ बताई थी, if my water content keeps on increasing, what will happen to your apparent cohesion? Apparent cohesion decreases. याद है ना? Okay, so if you keep on adding water, what will happen? Your apparent cohesion is decreasing, so because of it, what will happen? Again your volume will start to decrease. Okay, initially dry sample tha, let us say this is my dry sample, my volume is up to this level, my volume is up to this level. Now I had some water, as soon as I have added water, my volume has increased. But if you keep on adding water, my volume will again start to decrease. Okay, you can see the volume increased, now again the volume has started to decrease. Okay, if you keep on adding water, if you saturated it, what will happen? If it is completely saturated, then your meniscus is completely destroyed. अभी तो पढ़ा था, your meniscus will be completely destroyed. So if your meniscus is completely destroyed, your tension is zero. If your surface tension is zero, there is no apparent cohesion. अगर apparent cohesion ही नहीं है, तो whatever is there, whatever volume change was there, it is completely gone. Increase in volume, whatever was there, it will be reduced back to zero. Things are clear? So obviously your bulking, it will be more in fine sand compared to that of medium sand, and medium sand will be more compared to that of coarse sand. Common sense की बात है, right? So fine sand will have more compared to that of medium sand, and medium sand will have more compared to that of coarse sand. Okay, so why? Because in fine sand, if I have fine sand, even the voids will be small. If voids are small, more capillary action will be there, more surface tension will be acting. Okay, अगर voids are big, if I am taking coarse sand, what is happening, even the voids are big, तो इतना surface tension नहीं रहेगा, इतना tensile force act नहीं करेगा. So obviously your apparent cohesion will also be less, therefore bulking will also be less in coarse sand compared to that of fine sand. Common sense की बात है. Okay, I hope things are clear. And this is seen only in sand. याद रखना, very important. Bulking of clay नहीं रहेगा, bulking of silt नहीं रहेगा. It is seen only in sand. Why? Because clay and silt, right, they already have real cohesion in between them. उन्हें this fake cohesion का कोई ज़रूरत नहीं है. Okay, they have no need of this apparent cohesion. They have the real cohesion in between them. So it cannot be easily destroyed because of increasing water content. Okay, things are clear. And obviously I have told you, silt and clay, they can absorb more amount of water. They can absorb more amount of water. So obviously there will be certain amount of water. So even if you are adding water, there won't be any huge change in volume. Things are clear? Okay. So ये graph याद रख लेना. Bulking with respect to water content. If you are adding water, your bulking will first increase, and again it will be coming back to its original position. Okay, it will be coming back to its original volume. Fine sand का ज़्यादा रहेगा compared to medium sand, and medium sand का ज़्यादा रहेगा compared to that of coarse sand. And this bulking is maximum in the water content range of 5 to 6%. Very important bit, 5 to 6% में ज़्यादा रहेगा. Okay, याद रख लेना. The bulking is seen maximum when the water content is in the range of 5 to 6. Super important bit. Super important bit. Small PSC is repeatedly asked. Almost all exams. PSC में पूछ चुका है, SSC में पूछ चुका है, RRB में, JEE में भी पूछ चुका है. Coming to the last topic of today's module, which is slaking of clay. काफ़ी simple है. See, when I'm talking about clay, it will have some intermolecular force of attraction, which is called as cohesion, right? Okay, you know this, right? So, if you are taking a clay which is partially saturated, or to be precise, take a clay which is dried below your shrinkage limit. When I am telling you it is dried below shrinkage limit, what is shrinkage limit? It is the water content at which the soil is just saturated. Okay, so it was saturated up to your shrinkage limit, but now you have to dry it below shrinkage limit. Yani there is certain air voids present in your soil sample now. Great. So take this soil sample which is clay here. Slaking is present only in fine grain soil, that too in clay. Yaad rakhna ye bit. So what is happening? Just throw this clay in your water beaker. Okay, whatever, एक water का flask ले लेना and throw this soil sample. Now what will happen? What will happen? ये जो air molecules है उसको replace करने लग जाएगा water. Agreed? So the water is trying to replace this air molecules. But three phase diagram में नहीं रहेगा ना. In real condition it is something like this. The voids are somewhere in between this soil solids. Okay, so what is happening? This water is trying to replace it, but it cannot go so easily, right? Because there is some intermolecular force of attraction between this soil solids, so they cannot easily move. There is some force of attraction, so it cannot easily move. But these air pockets are being occupied by water, so what will happen? There will be a very high pressure being developed and there will be a explosion. There will be some explosion. Yani the clay becomes soft and wet mass. उसका volume sudden से change हो जाएगा. Volume of change आप नहीं देखोगे because this is already present in water, right? So you can say there will be subsequent explosion and clay becomes very soft and wet mass. As simple as that. Okay. So this phenomena is called as slaking of clay. This phenomena is called as slaking of clay. This slaking of clay cannot be seen in sand. Why? अरे भैया sand में तो contact pressure है ही नहीं है ना. In sand our contact pressure is very less. There is no cohesion, right? There is no intermolecular force of attraction like cohesion. So what is happening? Our contact pressure whichever is there, it is very less. So जो air pocket है वो solid को side कर देगा and it will be released. So there won't be any such explosion when I am taking sand into consideration. Okay, so this explosion due to high pressure, it is possible only in clay. So I am calling it as slaking of clay. Okay, that's it for this module number 11. I hope you have enjoyed it, right? अगर कोई डाउट है तो व्हाट्सएप ग्रुप में पोस्ट कर देना, क्लियर कर दूंगा. In the next module, I am going to teach you soil structure and I will also try to complete this entire chapter. Okay, see you in module number 12.